All right, so today we are looking at 2.2.5, and it says how big is part of a part, multiplication of portions. And so you have seen Cecil's repeated integer-sized moves that can be represented with addition or multiplication. But what if you need to calculate part of a whole? For example, if 200 people enter a competition and 1/4 of them are chosen for the final round, how do you calculate how many were chosen? Sometimes you may even need to calculate a part of a part. For example, if Cameron sprinted 2/3 of a 1/4 mile track, how would you calculate how far Cameron sprinted? So today you will use different models to help you answer these types of questions. So this first question is all about Cecil and his tightrope. So here we see him balancing on one leg with his blindfold on. And it says Cecil has created a spectacular routine. His routine has two parts. The first part consists of a series of creative leaps followed by a somersault. The first part ends when Cecil does an elaborate bow while balancing on one toe. Then he moves into the second part of the routine, which includes several backflips and spins. When performed perfectly, the routine moves Cecil exactly to the other end of his tightrope. The routine can be represented by the following expressions. First, here's the first part of the routine. This is part 1. And then we see here 3, and then in parentheses 2, 3, and then in parentheses 3. So what is that telling us? Well, when we rewrote addition as multiplication, we could say 2 plus 2 plus 2 as 3 times 2. And then for 3 times 3, we could say 3 plus 3 plus 3. It's just an easier way to write it. This way is multiplication. All right? So then he pauses after that first part, and then he takes a bow in place. Then part 2 comes in. All right, and here again we see 4 on the outside of 1 plus -1 in parentheses, and we see 3 on the outside of 5 plus -2 in parentheses. Okay, so here we have some more multiplication. Now this time it is all about distributive property, meaning we take that number on the outside, multiply it by what's on the inside, and multiply it by what's on the inside. All right, so for example, this 4 with 1 plus -1 on the inside would turn into, well, 4 times 1 is 4, plus, and then 4 times -1 would be -4. These would actually cancel out. All right, so now that we understand what we're looking at, then we can work with our teammates and complete this problem here. So it says, draw an accurate diagram drawn to scale to represent Cecil's routine. Then answer the following questions and be ready to share your reasoning. Assume that the numbers used to describe the routine represent feet. All right, so the first part says, how long is Cecil's tightrope? How far from the starting point is Cecil when he takes his first bow? All right, so let's go ahead and calculate it. We can actually draw a diagram. I like to use green and red to show positive and negative. And so here he's going forward 2 feet 3 times. 2, 3. Okay, so if he's going forward 3 times each 2 feet, then he's going to be at 6 feet. And now we're going forward 3, 3, 3. So we were at 6 right here, a 6. And then 3 would be 9, another 3 would be 12, another 3 would be 15. Okay, so we're at 15 right here. And now we're going in the negative direction because we're adding -5. So I'm going to bring out my red. Since we're at 15, we're going to go back 5. And now we should be at 10. And now we're going to add 4 back. So we're at 10. Now we're going to add 4. And so now we should be at 14. All right. So then he pauses and takes a bow in place. So how long is Cecil's tightrope? Well, we can see how far he first went. He's gone at least 24 feet. 24 feet would be the length of his tightrope. And then how far is he from the starting point? Well, he'd be 14 feet when he takes that bow. All right. So this is when he takes his bow. This is the total length of his tightrope. All right. Now it says, what portion of the tightrope length does Cecil travel in each part of the routine? All right. So let's look at the second part here. Right now Cecil's at 14 feet after part 1. Now we go into part 2. So it says 5 plus 3. So we're at 8 plus, and we said this cancels out, negative 3. So if we go add negative 3, we're at 5. And then if we add negative 5, we're going to be at 0. And then here we have to do a little bit of math. Distributive property. First we're going to do 3 times 5. That's going to be 15. 3 times negative 2 gives us negative 6. And then we have that plus 1 at the end. So if we do 0 plus 15 gives us 15. And then if we add our negative 6 here, that's going to bring us back down to 9. And then we're going to add 1 here at the end, which will bring us to 10. All right, so that's how we get to this 24 feet that I was talking about in reference to the total length. Because if you take the 14 feet that he went in the first part and then add 10 more feet to it, oh my goodness, and you're going to get 24 feet in total. First part's going to be, so part 1, it's going to be 14 feet. Part 2 is going to be 10 feet, okay? And see, if we look at portion of the tightrope of Cecil travel in each part, well, he travels 14 feet out of the 24 feet in part 1. And if we simplify that, we could divide each by 2, and then it would be 7 over 12. And then if we look at part 2, well, he travels 10 feet, so that's 10 over 24. And if we simplify that, we're going to have 5 over 12, right? If you divide each by 2. And you'll see if we add them together, 7/12 plus 5/12, we're going to get 12/12 or 1, right? 24 out of 24. So that says C, Cecil had only completed 2/3 of his routine when a rather violent sneeze caused him to fall. How far from the starting point was Cecil when he sneezed and fell? Okay, 2/3 of his routine. Well, his routine consists of how many moves? That's what I'm looking at. So we have 1 move, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. He has 11 moves. That may be kind of tough to find 2/3 of. So let's just take a look at the total length of the rope. Well, the total length of the rope is 24 feet. So if we wanted to figure out of 24 what 2/3 would be, you can multiply 3 by 8 to get to 24. So let's multiply 2 by 8 to get to 16. So you could say 16 feet would be the total length of the rope. But as far as his routine, it's kind of tough because he made 11 moves. Well, maybe we could break this down even more. Let's see. He did this first part 3 times, so we're at 3. Second part he did another 3 times, so we're at 6. Then a move here, another move number 10, and then here he did this move 4 times, so I'm going to say 14 times. And then another move, so we're at 15, another move 16, and 3 moves here, so we're going to do 19, and then a final move that puts us at 20. Can we do 2/3 of 20? Still kind of tough, but we'll go for it. 2/3 of 20 would be about 13 moves. So let's put a halt about right here. All right. So where's Cecil at right before he gets to this 4 multiplied by 1 plus -1? Let's see. He's at 14 feet, and then he adds 8 more. So he'd be at 22 feet out of the 24, 2/3 of the way through his routine. So he's almost at the end, but he's not quite. 22 feet out of 24 feet when he had that sneeze. All right, the next part is 286. Garden Road Middle School is planning on a field trip for students to attend a conference about careers in mathematics. Half of the students signed up to go on the field trip, but only 3/4 of those students brought back their permission slips to attend the field trip. Explore what fraction of students in the school will be able to go on the field trip. So it says, discuss this problem with your team. Do you have to know how many students go to Garden Road Middle School to be able to answer this question? Why or why not? Once you have reached agreement on this issue, ask your teacher for the lesson resource page. All right, you guys won't be getting that. Or draw 8 identical rectangles on a full sheet of paper. Then follow the steps below to answer the question. The entire school's enrollment, no matter what it is, can be represented with an unshaded unit rectangle. As shown at right, half of the students at the school plan to attend. Also, we have that right down here. Half the students plan to attend. To show this, divide your rectangle into 2 equal pieces, as shown below. Then lightly shade and label 1/2 to show the half the school is planning to attend. And here they have that right here. Label the other half with the appropriate label. So now the questions are down here, and it says, first one, 3/4 of the students planning to attend brought back their permission slips to go to the conference. Represent this portion on your rectangle. So here we already have our half. And so we're going to take this half and we're going to divide it into fourths, right? Because we want 3/4. So now I've divided into 1, 2, 3, 4 parts, and a fourth or 3/4 of them are going on this trip. So I'm going to shade 3/4. And then what fraction of the whole school will attend this conference? Well, I'm going to extend these blue lines up. And now we've made it into eighths, and you'll see that 3 out of the 8 squares are filled up. So 3 out of the 8 total squares. So that'd be a fraction of the whole school. What if the total school population is 120 students, how many would attend? So now we need to do 3/8 equal to what out of 120? Okay, well, we had to multiply 8 by what to get to 120? That's what I'm looking at. Well, let's see. I know 8 times 8 is 64. 64 multiplied by 2, which would be 128, and this is 1 less than that. This is 120, so it'd be 16. 1 less would be 15, so multiply it by 15. Multiply the top by 15. All right, so if we do 3 times 15, we're going to get 45. So my answer would be 45 students. And then an additional challenge, how do you know that the school population cannot be either 125 or 250?